Second. A very warm and hearty welcome to all on this Friday evening. We're very pleased to have with us today Dr.Suvarna Joshi, Associate Professor at Microbiology at the Government Medical College of Pune. Dr. Joshi comes with an extensive experience of almost 3 decades, I would say 29 years of experience in the field of education and medical diagnostics. She is no stranger to achievements, having received fellowships from the Johns Hopkins University in Baltimore, recipient of the UNESCO Award from the American Society of Microbiology Award, and having completed more than 25 publications and 10 research projects funded by the ICMR and various international journals. She has been the ex-secretary of the IAMM, Maharashtra chapter, and her work in the COVID pandemic brings her to good repute, having headed up the COVID force in Pune, and she is a true COVID warrior in every sense of the word. But today she's here to talk about dengue. Dengue is a vector-borne disease which has wrought havoc across the country for the last decade and a half. Many say that it has become endemic in many parts of the country. And there are new trends in dengue diagnosis emerging every day. So without further ado, I hand over the forum to Dr. Suvarna Joshi from BJ Medical College, Pune. Ma'am, over to you.
Thank you, sir, for introduction. Good evening, all. We will be discussing the emerging trends in dengue diagnosis. After the COVID is coming to the end, why we have chosen this dengue topic? So because this dengue disease is every year the government of India celebrate National Dengue Day on May 16th. This is why this May 16th is being chosen as a date for National Dengue Day. It is just before the transmission season starts for the vector. This is the initiative, as I said, by the Ministry of Health and Family Welfare. The main purpose of this dengue day is to create awareness about dengue and to intensify the preventive measures and preparedness for control. For this year, the slogan is dengue is preventable and let's join hands. Now, in brief, the morphology of the dengue virus. This dengue virus is belongs to the flavivirus group and is a positive sense single-stranded RNA with 11,000 base pair nucleotide or 11 kb size. It is spherical in structure and size is about 50 nanometer. You can see the comparatively smooth surface of a mature virion. On the outer side or on the outer surface, it has a protein layer below which there is a lipid bilayer, and below the lipid bilayer is a nucleocapsid. All these are present as an antigen on the dengue virus. The dengue RNA, which is a positive sense single-stranded RNA, code for 3 structural protein and 7 non-structural protein as shown in this figure. These are the NMR nuclear magnetic resonance structures of this predominant antigen, that is the M protein, envelope protein, and the NS3, and these non-structural proteins mainly act as enzymes which is required for the replication of virus within the host cell. This is the slide which shows that how during the replication of the virus in the host cell, the virus replication is going on in the endoplasmic reticulum. And this is the typical cycle of that. Once we understand that, we'll come to the different antigens which are used for the diagnosis of the dengue disease. The dengue viral infection, as per the WHO, is classified into asymptomatic and symptomatic. The symptomatic are further divided into undifferentiated fever, which is very mild, to the extended hemorrhagic or the very severe manifestation as dengue hemorrhagic fever or dengue shock. They may present with the warning signs for the severe disease, which are like severe plasma leakage, severe hemorrhage, or the organ impairment as such. Coming to the laboratory diagnosis of dengue from the microbiology point of view, whenever you are selecting the test for diagnosis of dengue, it mainly depends on the indications for which you are going to use the test. So as we all know, the rapid and accurate diagnosis is of paramount importance. So the test which we are using it for clinical management of the case, for epidemiological surveillance, we will be using mainly only the antibody test, and for vaccine trial, mainly the neutralizing antibody, we are using it. So based on the indication, the choice of the test has to be decided. The tests which are available for the diagnosis of dengue are, as we all know, is the isolation of the virus from various clinical specimens and their identification as serotype or further as a genotype, depending on the aim of the study. Then the detection of viral nucleic acid, that is RNA, detection of viral antigen, mainly the antigen which is used in diagnosis of dengue is non-structural protein 1, that is NS1 antigen. Then in the later stage of the disease, the diagnosis is mainly based on the immunological response, that is on the detection of IgM or IgG antibodies. And for clinical management, the other hematological parameters are of vital importance. If you see the tests which are available, microbiological tests which are available for diagnosis, they can be broadly classified into direct methods and indirect methods. If you see the accessibility to the towards the diagnostic test, so the indirect methods are easy, simple to do, and low cost compared to the direct methods. But the direct methods gives you more confidence than the indirect one. So how do we go about it? When the patient gives you the history of symptoms for less than 7 days, then one should go for viral RNA detection or viral antigen detection. Viral isolation, and if it is the facilities are available, then only it is recommended. So most of the diagnostic lab do not have this facility. So I am saying like mainly one can go for the antigen detection or RNA detection, and detection of IgM antibody, which can appear in the first week of illness. After, if the history is given for more than 7 days, then the antibody is the choice for diagnosis. And mainly we should look for the seroconversion to IgM, or if IgG are detected in the acute phase sample, then one should go for fold-fold rise in the IgG titer. Apart from that, for primary and secondary dengue, the hemagglutination inhibition test has been used, which is the so-called historical test, or one can go for the plaque reduction neutralization test. These are also nowadays replaced by the newer version. So if the single IgM test is positive on a single acute sera, we label it as a highly suggestive test and not confirmed. For confirmation, we say like a single PCR test positive or virus isolation is positive, seroconversion into negative to IgM positive in paired sera, or fourfold rise in IgG in a paired sera. If the IgG came positive in a single serum sample, then it should be of high titer, or you can confirm by doing the hemagglutination inhibition test with the titer more than 1280 or more. Now, I'm just giving you the comparison in the way that what are currently available tests and what are the new emerging tests. For isolation of virus or for cultivation of virus, initially the inoculation into the vectors, that is various species of mosquito, Aedes species of mosquito are being used, and in those the dengue virus is generally replicate and the titer has been counted in terms of minimal infective dose, right? But nowadays they have shifted it to the inoculation into the various insect cell lines. The most commonly used insect cell lines are C6/36, a clone which is being prepared from the Aedes albopictus. Another cell lines currently which are being used and tried and giving good results are LLCMK2 or baby's hamster kidney cell line, that is BHK21. Whenever we are using these insect cell lines, then the virus multiplication or the viral particle can be detected, or the isolation is confirmed by doing the presence, doing the test for presence of antigen in the cell by either immunofluorescence, or viral titer can be measured by RT-PCR, quantitative RT-PCR. Sometimes you can go for cytopathic effect or plaque formation in mammalian cells, but all the cells, or the what you can say, the all the virus serotypes or the genotypes may not give cytopathic effect if the viral load is less. So it may be less efficient compared to the RT-PCR or IFA for the detection of growth in the cell line. Now coming to the viral RNA detection test, the currently the tests which are in use are the RT-PCR singleplex or multiplex RT-PCR. Before that, we were having the nested PCR single step or two step which were available. Before this COVID pandemic, approach or availability of RT-PCR is very difficult, and because of that, the newer test or the various versions of or modifications of amplification test has been tried. Few of them I will be discussing here. One is NASBA and second one is RT-LAMP. Apart from that, the microarray is also being reported for the multiple infection simultaneously you can test in, or the simple way you can do the TrueNAT system on which you just have to, it's a type of RT-PCR which is now available. In the RT-PCR also, initially only the single dengue kit was available. Later on, they had made it the detection kit available as sort of a multiplex where you can do the dengue, chikungunya simultaneously and Zika simultaneously. Some company had come up with the tropical diseases kit, which includes not only the dengue, chikungunya and Zika, but also include the bacterial infections like leptospira, then salmonella, then even the rickettsial infections. They are covered in this multiplex PCR. So newer test kits are coming up with the multiplex, which are economical and comparatively easy rather than doing 10 tests separately. Now coming to this newer technique, that is NASBA, nucleic acid amplification, nucleic acid sequence based amplification test. The major advantage of this test is that it is isothermal, so no need to have the thermal cycler. This may sound odd because most of the laboratories are now having RT-PCR or the thermal cycler available in the laboratories. But as I said, before the COVID era, this was not possible in most of the lab, and that's why these techniques has been evolved. The major advantage of this NASBA technique is that it is used for RNA virus or for RNA detection. So the initial stage, you have the RNA and the end product is also RNA. In this system, initially there is a reverse transcriptase where the RNA target is copied into double-stranded DNA, and then that serves as a template for the RNA transcription. I will explain it to you in a simple way. Here you have initially the first as a RNA as a template, to which the primer P1 will attach, and then it will transcribe it into the DNA. Then comes this AMV reverse transcriptase enzyme. This reverse transcriptase enzyme will separate this RNA or cleave the RNA from this RNA DNA double stack. And then this primer 2 will come and attach, and with the help of this AMV reverse transcriptase enzyme, that AMV stands for avium myoblastosis reverse transcriptase enzyme, which will form again the double stranded DNA. Now, when this double stranded DNA is formed along with the tRNA polymerase, in presence of this tRNA polymerase, the peculiarity of this T7 polymerase is that it transcribes only double stranded DNA from its promoter region, and so you will have the number of antisense RNA with you, and that is how you will have the end product as RNA. This RNA can be detected by various methods, like fluorochrome can be used, or you can use the electrochemiluminescence method, or you can even use the gel electrophoresis for detection of product, or biotin streptavidin labeled probe can also be used for detection of this RNA which has been amplified. So it is very simple, does not require RT-PCR machine or any sophisticated instrument, and it's comparatively rapid even as compared to the RT-PCR, and has very low detection limit, that is 3.5 copies per microliter. And here it uses the 4 primers depending on the kit available. So you can go for the universal primer for the dengue for all 4 serotypes, or you can have the 4 different separately. Now coming to the next recent method which has been made available is the loop mediated amplification PCR, or the RT-LAMP test is the short form. This is sort of a sister of this NASBA test. In NASBA, you are detecting the RNA, and this RT-LAMP test is for the DNA. The LAMP test is mainly for the DNA, and by doing the RT-PCR, RT-LAMP test, you can even detect the presence of RNA in the original sample. Similar to the NASBA test, this is also very easy. The major advantage of this RT-LAMP test is that it uses multiple primers. So in RT-PCR, usually we use 1 single pair or 2 pair of primers. Here it uses at least 4 to 6 primers, specific primers for a single gene target, so that the amount of product which is generated is quite high compared to the RT-PCR, and plus it can be give you the more specificity. So along with this 4 to 6 primer pair, you can add the fluorescent detection reagent and your sample RNA from the RNA sample or the RNA template, and then along with the positive and negative control, you can incubate the tube for 63 degrees for 80 minutes and then inactivate it for 5 minutes further. Constantly, it takes the reading at 500 loop amp real-time turbidometer, and you can check the product by the turbidometer, because there is a magnesium which is forming the precipitate in the solution, and that gives you the turbidity at the end of the amplification cycles. So the threshold time value for the positivity by RT-LAMP was determined when the turbidity increased above the threshold value, and which is fixed to 0.07 absorbance units, and you can compare it with that. As I said, you can also monitor it with the colorimeter. Usually when you are using the fluorescence technique, then the positive reaction, you will get the green fluorescence, and under the UV radiation, you will see the positive sample with the white light, and with the negative control, you will have the orange, which is the original color, or no fluorescence, because there is no amplification. So these two, the RT lamp and the NASBA, are very simple test and ready to can be done in any molecular lab without much sophisticated instrument. Coming to the next test, which has been reported in various literature, is the microarray test. It makes it possible to screen the sample for different viruses at the same time, or in parallel, you can say, sort of a multiplex. And here you can see the nucleic acid is amplified before hybridization, and when you are carrying out the amplifications, you can decide the amplification strategy, that to target only the conserved region, or you can go also for the random base, so that you can identify that improves your mismatch, gives you the improvement in the ability to detect the diverged strain also. So in the microarray, there is for detection, there is a laser based scanner, which is commonly used to read the product which are being amplified and labeled with the fluorescent dye. This microarray can be useful to test the dengue virus and other viruses, as well as the pathogens which are giving clinically similar features as that of dengue like symptoms. So that is for the molecular test or the nucleic acid detection for the dengue virus, the newer tests which are now available. Now coming to the viral antigen detection test. Currently we all know that the rapid test, that is immunochromatography and dot blot test, are available, or one can go for the ELISA if the load is high. Then the day by day, I must tell here that initially the antigen which was used to produce the antibody for detection of NS1 are sort of a crude antigen, we can say, from the whole cell line lysate was used, and slowly the synthetic, they had moved from the recombinant to synthetic antigen preparation to raise the antibody or prepare the antibody. The newer tests which are available for detection of antigen are based on the fluorescence immunoassay, bead-based multiplex biomarkers, which is known as suspension array. There is a modification of this NS1 antigen ELISA, which can also be used for serotyping of dengue virus. Apart from that, MALDI-TOF MS is also useful for detection of dengue virus. Initially, the initial reports were only that it is available for dengue type 1 virus, and that is for the capsid antigen, but later on it was available for all 4 viruses. Coming to the first newer test, that is NS1 antigen QuantiCard test. The test area here is coated with the specific anti-dengue NS1 NS1 antibodies, and then if antigen is present in the patient sample, it will form complex with that NS1 antibodies which are conjugated with the fluorochrome, and on addition of assay buffer, this complex will migrate along the nitrocellulose membrane to the test region and form the antigen antibody complex, that is the fluorescence immunocomplex. It is similar to that of immunochromatography test, but the major advantage of this test is that here you get the unit, so that the subjectivity of the faint line, which always happens with the rapid test, that one person feel like it is positive, the second person feel like it is negative, it is not as strong as that of control, and so on and so forth. That subjectivity can be minimized over here because it has a separate reader which is known as iQuantAnalyzer. So here the company claims that the test can be capable of detecting infection from day 1, and it can detect all 4 serotypes. And individual cartridge is available in a single separated pouch, and the pack size is I think of 24, and the results are available within 30 minutes. The sensitivity, if you look at it, is quite high, and it is as good as that of ELISA. So compared to the ELISA, half the time is required, and many more such platforms are available from the different companies. Then coming to the suspension array, here I will come to in the end that which are the different tests we have done so far for diagnosis of dengue and what is our experience with the different systems. Now coming to the suspension array, it is based on the bead-based technique, where on the bead there are multiple antigens or the multiple biomarkers are coated. Here they had coated the NS1 antigen as well as the antibodies, IgG antibodies. So the in the suspension array, the classification fluorophore and the detection fluorophore are simultaneously going through that microfluidic chip and using the infinity corrected microscope system. So you put it under the microscope, which is having a laser beam as a source of light, and this detection fluorophore and the classification fluorophore, the machine does the comparison, and it gives you the calibration curve which was plotted for the median fluorescence intensity against the known concentration of NS1 protein and antibodies to NS1 protein, which is of IgG type. The kit claim that the detection limit is 7.8 nanogram per microliter and for the antigen, and 15.6 nanogram for the antibody. This is the diagrammatic representation here. Like this is the bead set A, and here it is the bead set B. Here the dengue NS1 antigen is shown with this blue color and the specific IgG. So this coated beads, it will go and bind over there, and sort of it becomes a sandwich, and you will be able to detect wherever the fluorescence or the reporter fluorescence molecule has been attached. So sort of a sandwich is took place on that bead. So the next test which I will be discussing is the serotyping NS1 ELISA. This is the newer one and simple one for the serotype identification compared to the other methods. Does not require any RT-PCR and any sophisticated or technically demanding tests. Simple ELISA you can carry out for the identification of the infection as well as the serotype identification. So here the 4 biotinylated serotype specific antibodies are applied, and you run the normal ELISA as you run it for the NS1 antigen, and it has claimed that it shows the 100% concordance with the standard RT-PCR for picking up correctly the all 4 serotypes with the sensitivity of 78%. And therefore they are claiming that it can be the alternative assay for early dengue diagnosis as well as for serotype identification, especially in a remote area where the resources are also limited and dengue endemic area is there. Then coming to the mass spectrophotometry or MADITOF, that is matrix assisted lesser deabsorption, ionization, flight of light, mass spectrometry. So it detects the type 1 dengue virus initially, as I said, and that to be the capsid antigen. So in fact, here what they have done is that they complete the capture it, the antigen by the immunocapture assembly, and then that assembly was put on the slide of MALDI-TOF, and then the matrix was layered on it, and then it was identified by the MALDI-TOF MS. So the biological mixture is treated with the magnetic particle coated with the monoclonal antibody directed against the type 1 virus antigen. And after the immune capture purification, this dengue virus antigen is eluted in the 30% acetic acid and then directly spotted on the seed layer method, and then analyzed by the MALDI-TOF MS for dengue type 1 capsid protein. Detection limit for this assay was 5 plaque forming units. That is what they claim. And the immunocapture can definitely differentiate dengue type 1 from other serotypes of dengue viruses as well as the other flaviviruses like Japanese encephalitis. Later on, the modification of this test has also come up, where, as I said, the NS1 antigen has also been used now for all 4 types, not only the capsid one. Now that is for the antigen detection, NS1 antigen, and they're coming up newer technology for the detection of it. Now, coming to the immunological response based test for diagnosis of dengue, that is test for IgM and IgG antibody detection. Currently, like that of NS1 test or NS1 antigen detection test, you have the, as we know, the rapid immunochromatography, ICT, the lateral flow, ELISA, and then the hemagglutination inhibition and the plaque reduction neutralization test. Here, as we all know, the different types of ELISA were initially available, but now once the central government has started the National Vector-Borne Disease Control Program, all the centers, all the laboratories which are participating in the National Vector-Borne Disease Control Program are having access to the MAC ELISA. So MAC IgM ELISA and MAC IgG ELISA are available for the diagnosis as well as for the surveillance. Among the ELISA, the MAC ELISA is the latest version of it, I can say. And the newer tests which are available are again the immunofluorescence for IgM, Fluorescent Immunoassay, IgMQuantiCard, IgGQuantiCard, or there are modifications of ELISA inhibition method for IgG and microneutralization assay, as well as there are further modification of IgG ELISA. I will come to that for differentiation of primary dengue from that of secondary dengue. Coming to the ELISA inhibition method, it is sort of a competitive ELISA where in this ELISA inhibition method or EIM method, which is used for detection of dengue IgG antibodies. Mainly, the principle of this test is that the competition of is going on for the antigen site by the IgG antibody from the patient sample and the conjugated human IgG anti-dengue. And that is how they are called it as a ELISA inhibition method. So it is useful for serological diagnosis in the, as I said, after 7 days of symptoms, or you can use it for the surveillance purpose also. Now coming to the test for differentiation of primary dengue from that of secondary dengue infection. Whatever test we have seen so far, whether it is the virus isolation or whether it is the RT-PCR test or whether it is the antigen detection test, NS1 antigen test for various method, whether it's the newer methods or the old standard conventional method, none of them can detect the primary dengue from that of secondary dengue. So for differentiation, you have to rely on the immune response of the host. The currently used methods, as we all know, is the hemagglutination inhibition. Usually, we'll come to that hemagglutination inhibition test later on. And the simpler one is you can take the ratio of IgM and IgG optical density or the OD when you perform the ELISA. When the serum is diluted 1:20, then you can take the ratio 1:2 as significant for primary dengue to differentiate it primary dengue from secondary dengue. And if the serum sample is diluted 1:100, then the ratio should be 1:4. There are some references which says that if you go on increasing the ratio, then you get the more specificity. And some references, I came across the reference which says that 2.4 to 2.6, if you take that ratio, then you can identify 100% of secondary dengue cases. Now coming to the major disadvantage sort of the currently available test for differentiation of primary dengue from that of secondary dengue is that you need to have the paired sera, the sample collected during the acute phase as well as from the convalescent phase, or at least there should be the gap of 7 to 10 days between the two samples. And then you need to perform the test simultaneously on both these serum sample at the same time. Then there is a newer test which is available is the avidity IgG ELISA. Now in this avidity IgG ELISA, the major advantage is that there is no need to have the paired sera, because that is the problem in most of the diagnostic laboratories, that how many times you say it to the clinician that you need to have the paired sera, but maybe patient get discharged or whatever is the reason, hardly any time you get a paired sera. So you need to do something on the single serum sample which you have for differentiation, and this is a good test which is available. Here what we do, after you add the patient sample in a microtiter plate which are coated with the antigen, you have to put the sample in duplicate, and after the incubation you have to do the washing with the PBS, phosphate buffer saline, in one set, and in the other set you have to add the urea. So the different percentage of urea can be added, and the various references you will find like 6 molar to 8 molar urea in PBS can be used, and you can add that in the second set and incubate it. And then after that the simple washing steps are being done and the normal ELISA is being performed, and you take the OD. Then to calculate the avidity index, you have to take the OD you obtained in the well where you have treated it with the urea, divided by the optical density you obtained in the well where you have not used the urea for washing. Multiply it by 100, and that is how you will get the avidity index. And you can see here in one reference I found like it's very clearly you can differentiate the primary dengue infection from that of secondary dengue infection on a single sample, and all 4 different serotypes can be easily differentiated. At the primary dengue infection, naturally the avidity will be less, so you will have the avidity index low, and like 24.9 for dengue 1, whereas in secondary dengue you have it 76.2. So for all 4 you have a significant difference in the avidity index. So this is one of the simplest tests and can be easily done on the single sample which is available to you. Then coming to the plaque reduction neutralization test. This plaque reduction neutralization test is sort of a test which is restricted to the research laboratory, one can say, because there are many standardization is required, not only for this plaque reduction, also for the hemagglutination inhibition. Here we measure the antibodies that neutralize and prevent the virus from infecting the culture cell. So if you do not get the cytopathic effect or cell is not get infected, that means the patient's serum contains the antibody. So currently it is the most virus specific serological test for flaviviruses and also for the dengue serotype. Mainly used for quantification of neutralizing antibodies. And as I said, the principle is that neutralizing antibodies in patient sample inactivate the virus so that it has no longer capable of infecting and replicating the target cell. There are various modifications which are now available. So different cell lines, as I shown it in the virus isolation method, you can have the different cell lines that can be used for this plaque reduction test. So one is the micrometabolic inhibition test using baby hamster kidney cell line, that is BHK21, and the microculture plaque reduction using the second line LLC-MK2 cell line. The second modification, rather than using that insect cell line, that is C6-36, you can use these two cell lines. The second modification is the microplate culture using BHK21 cells, and you do the focus reduction method using peroxidase, antiperoxidase staining, rather than looking for the cytopathic effect or the plaque reduction in the entire well. You can do the focus reduction method by doing the peroxidase, antiperoxidase staining. Then the third modification is that you can go for the semi-micro method, you can say. Mainly it has been tried on the LLC-MK2 cell line, where they are using the 70% plaque reduction criteria. And a simplified plaque reduction neutralizing assay using baby hamster kidney cell line is also big there. I will not discuss this much because nobody is doing that, I guess, in a diagnostic laboratory. It is mainly done in a research laboratory. Now coming to the hemagglutination inhibition test. As I said, this is the second test which is mainly done in a research laboratory. The principle of the test is, it is mainly based on the ability of the dengue antigen to agglutinate the RBCs of gander or trypsinize human RBCs of O blood group. The anti-dengue antibodies, if present in the serum of a patient, then it will inhibit this agglutination, and the potency of this inhibition is measured in the hemagglutination inhibition test. So for this, the serum sample is first treated with acetone or kaolin. This treatment is necessary to remove the non-specific inhibitors of hemagglutination. Then it is adsorbed on the gander or trypsinase type of O blood group positive RBC to remove the non-specific agglutinin. Here you have to have the standardization or optimization for each batch of antigen which you are using it, as well as the set of RBC. Similarly, the different type of serotypes of dengue virus hemagglutinins requires different buffers with different pH. So you have to have what we call it as a pH optima, requires to use the multiple different pH buffers for each serotypes, because you don't know like which serotype is the infecting in the patient's to the patient. Okay, and again the one more disadvantage, like as I said, you have to have the paired sera here. Response to primary infection is characterized by the low level of antibodies in acute phase sample, and slowly the antibody titer increases, and in the secondary dengue you will find that hemagglutination inhibition antibody test, the antibody titer will go rapidly and it can be there more than 1:1280. So value below this, that is 642/1280, is usually considered as a positive for primary dengue, and for more than that we call it as a secondary dengue. However, one has to remember that this assay does not discriminate. It is unable to differentiate between the closely related flavivirus, and neither you can make out like which type of antibodies isotypes you cannot measure out or you cannot identify. So this is a diagrammatic representation of the hemagglutination inhibition test. So you have the dengue virus antigen and the RBC, and then you mix with the patient serum sample, and then if the patient serum sample contains the antibody, they will attach to the antigen and will not remain free to lyse the RBC. One more test which has a similar principle as that of plaque reduction neutralization test is the microneutralization assay. It is a miniature sort of. Instead of counting the number of plaque per well, here what we do, we stain the viral antigen by using the labeled antibody, and you quantify the amount of antigen by colorimetric method. So it is designed to use a smaller amount of reagents for testing the large number of samples. And in viral detection test, here you have to take care to avoid the measurement of growth after many replication cycles. So when you are putting the patient sample cell line with the viral culture, and then putting the patient sample where it will have the antibody and overlaying it with the agarose. So you have to standardize like how much time or duration required for each serotype. That's the time duration required for inoculation and taking the reading. Otherwise, what will happen? You will have the multiple replication cycles and then you will be taking the reading, and that will affect the results. And since you have to take care, because as I said, since not all viruses grow at the same rate, at the same incubation period, and so you have to take that care. Now, recently, if you see the literature, review the literature, you will find like various biomarkers has been coming up day by day. Every day you will find a new marker which has been come up. So in I had found one this thing where they have screened the entire 15-mer peptide microarray library of proteomes of all 4 dengue virus. So all 4 dengue virus protein library, microarray library, they had screened, and they had identified, screen it with the help of known positive serum samples, which are having the dengue positive samples, and they had identified the 9 peptides among these entire proteomes of 4 dengue virus, where they had found the 9 peptides which are identified by IgM. They had labeled it as PM. And there were 11 peptides which has been picked up or which show reaction with the IgG type of IgG dengue antibody. So they made a set of this 9 + 11, 20 biomarkers for the identification of infection. And they had coated it on the bead, and they made it as a bead-based multiplex peptide immunoassay. They labeled it as MPIA, a bead-based multiplex peptide immunoassay. And for detection, they had used the Luminex technology. Okay, these 9 peptides, which has been identified by the IgM type of dengue antibodies, their location was in the E protein, NS1, NS2A, NS2B, N3, and NS3 and NS4B proteins, while for the peptides which are being identified for by IgG type of antibodies, it is M protein, E protein, and NS1, NS2B, NS3, NS4B, as well as NS5 protein. So sort of they had put all the proteins which has been identified differently by some of the IgG and some of the IgM, pulled together, coated on the bead, and use this multiplex peptide immunoassay for detection of dengue infection. And for the now the problem will be like which combination of these and 20 peptides will be useful to say that infection is there or not, and how many minimum will be there to say that which infection it is. So for that they have used the machine, artificial intelligence they had used, and with that they have developed the random forest algorithm by the machine. Now, as I said, this is the overall various technologies which are coming up. Various biomarkers are there which are come up either by the proteomics or the genetic this thing, or what we can say it as a identify the gene and put it in the recombinant technology, or the proteomics is being used for identifying the various markers for serotype specific dengue virus and use it for detection by various detection systems. You go for either fluorescence or biotin label, colloidal gold, or even the nanoparticles. I came across some references where they have said like for detection of product in the RT-LAMP test or even in the NASBA, they have used for product detection the nanoparticles. And in that test, what they had mentioned on the nitrocellulose membrane, they put the anti-dengue probe, and to that the product is added, and on top of they have added the nanoparticle, nanogold particle, which are coated with the reporter probe. And there is a sandwich between this reporter probe and the nitrocellulose membrane to which the you have the attached dengue specific probe, and you can identify the product in the LAMP test as well as in the NASBA method. So various newer technology has come up. Not only that, for the management or the clinical monitoring of the patient, they had come up with the various non-invasive method to keep monitoring the blood pressure and pulse rate like multipara. So you just have a jackets or the wristband or something like that, electronic this thing, and that can be used for monitoring constantly the patient, whether he is going towards the dengue, severe dengue with some warning signs. That can also be done. You will find a number of references for that also. Now this slide shows our experience for last 12 years, 10 years. Mainly the national, as I said, the National Vector-Borne Disease Control Program has started in 2004 onwards regularly. And this is the data for last 10 years from 2012 to 2022. This in between 2020 to 2021 has gone mainly in the COVID. So we have very less samples, but still over the 10 years period, we have tested some around somewhere around 42,000 samples, which has been tested by IgMAC ELISA, and simultaneously 15,000 samples, out of which we have also tested it by the NS1 antigen ELISA, and you can see the positivity. So none of the year we have the less than 10% positivity. But here what we do that those samples which we received for dengue testing, since clinically it is difficult to differentiate whether it is chikungunya, we also test the samples for chikungunya also. And what we have found that after 2016, there is a sort of a shift from a dengue to chikungunya. So many say in 2016, the chikungunya positivity was 25%, while for that of dengue, it was only 12%. So it was alternate year, it was coming 1 year dengue more common than the chikungunya, like that it was happening from 2016 onwards. Not only we have the experience of doing this MAC ELISA for IgM, and we have also done about 300 samples for differentiation of primary dengue from that of secondary dengue using IgG ELISA. And what we have found, like roughly around 12% of samples we could make out by doing only IgG, whether it is, and taking the ratio of IgM IgG, whether they are the secondary dengue, and it was very helpful for the clinical management of the patient. As we all know, these secondary dengue patients likely to develop more severe condition than the primary one. These are some of my references. There are many more which I had referred. Not only that, we have also done the testing for some of the 200-300 samples we have done with this fluorescent immunoassay. What is in market, it is available as a QuantiCard, and we had found a good experience. Even though as they said, not 100% sensitive, but we had found it 95% sensitive and 96% specific for NS1 as well as for IgM and IgG. Apart from that, we have also used the multiplex RT-PCR kit for tropical diseases for around 200-300 samples, where we have used it for dengue, chikungunya, Zika, rickettsia, scrub typhus, malaria, leptospira, and enteric fever, that is salmonella, in a single reaction. And we had once a kit for only dengue, chikungunya PCR. So we have also compared the this QuantiCard results with the PCR as well as NS1 ELISA and IgM IgG ELISA, and we found it very good results with that. Thank you for patient listening, and that's all from my side. If anyone has some discussion, I'm ready for that. Thank you, sir.
Thank you very much, Dr. Joshi. As a as a manager with JMitra, I do realize that we focus on rapid tests, we focus on the fluorescent immunoassay, and of course we focus on the ELISA test. It takes a lot of research at your end to actually make us aware that the number of tests available for dengue diagnosis, the number of accurate tests available is very, very high actually. So, thank you for that, sharing those insights with us, and especially the detailed insights on various tests, the pros, the cons, what the claims are, and what your actual experience has been vis-a-vis those tests. Ma'am, I had a couple of questions.
Okay.
So in 2020, when the COVID pandemic was on, do you think at some level that we neglected dengue? I mean, the numbers obviously, because testing was mostly happening for COVID. So the number of tests that happened were lower.
Yes. So we don't know whether it was there or it was not there, or whether there are co-infection. There are reports like co-infection of COVID and dengue together. There are some references saying that there is a cross-reactivity of dengue antibodies with the COVID, but I really have no first-hand experience for that, because my assumption is that Pune being an endemic area, if we already have the antibodies for dengue, how do we know that whether it is cross-reacting with it, or really you need to find out whether that patient has a history of something dengue or dengue-like illness, and it is showing reaction with that. But there are reports which shows the co-infection as well as the cross-reactivity.
All right.
One more point I wanted to say, that mainly the rapid tests are given less importance, saying that it has a cross-reactivity with other flaviviruses. But if you see the literature where they say that other flaviviruses are mainly the Zika and yellow fever, which is not there in India.
Absolutely.
So we don't have to worry about the cross-reactivity, and usually There is one paper where they had compared the 7 different rapid tests and as well as ELISA, and they had found that the cross reactivity with Zika and yellow fever is very at low concentration of plaque forming units compared to the dengue. So it is very less likely as what we are, maybe because of the more purification or more perfect antigen is being chosen for the test detection, maybe the reason. Over the years, from the wholesale lysate to the proteomics, we are moving towards more and more specific antigen, maybe the reason for improving in the specificity.
Ma'am, I can tell you very honestly that I'm associated with the manufacturer of dengue tests, and we have been working continuously to innovate on the product. In fact, Fluorescent Immunoassay is a new addition to our portfolio. But ma'am, from the Indian perspective, you highlighted a lot of tests out here, but given the Indian scenario in tier 2 and tier 3 cities, is there any gold, not a gold standard, but is there any system that you would, algorithm that you would like to recommend, that would really make things easier for everyone? Because RT-PCR, while the machines are there in the country today, it's still not the easiest test to perform, if I'm not wrong, right? So, ma'am, any recommendation that you have, not with the brand, I'm just asking about an algorithm that physicians or clinicians can follow to diagnose dengue, ma'am?
Yes, as I shown it in my slide, it one has to take the detailed history of the duration of symptoms. How long is the symptoms, and based on that you can select the first antigen test and IgM ELISA. And if the IgG ELISA, if the both are negative, then one can go for IgG to find out whether it is a secondary dengue, if it is a known endemic area for dengue. So that algorithm can be there, and based on the what you can say economy, like whether the rapid tests are available or whether ELISA is available. So it is easy to do the rapid test, so the rapid test can be done first. We have an experience that among the rapid test, the NS1 antigen rapid test is performing better and having more than 75% sensitivity compared to the IgM IgG rapid test. So I think there is no harm in going first hand with the rapid NS1 test, whichever is the methodology or the principle base, that can pick up easily the patient in acute phase.
Right, ma'am. Thank you so much. I think that's all about we have time for today. Ma'am, right, this presentation has been just in time, right in time before the monsoons hit us in West India and the mosquitoes take charge.
Yes,
hopefully
so everybody must be aware of it.
Yes. Hopefully people will take the right precautions and we don't have an epidemic or a situation like we had last year.
Yes.
So, thank you very much for your time, ma'am.
Thank you. Have a good day.
Thank you, ma'am. Thank you, everybody who attending. We'll see you soon for the next JSS from JMitra.
Thank you.